Hello, everyone, and thank you for joining us this evening for the second week of the RISE Institute and Rugby Research and Injury Prevention Group's 2026 Sports Science Series. We will begin with our first sports science presentation with a presentation from Jason Tay. Jason, I'll let you introduce yourself and your presentation, and you can start screen sharing when you're ready.
All right. Hi, Daniel. Thanks for the introduction. I'm just send a sharing request real quick. Okay. All right. Can anyone see my screen? All right. Hi, everyone. My name is Jason Tay. As stated, I'm a rising junior in St. Mark's School in Massachusetts. And today I'm presenting on a paper called Training, Load Monitoring in Team Sports, a novel framework separating physiological and biomechanical load adaptation pathways, published in the Sports Medicine Journal in 2017 by, sorry if I mispronounced, but Van Rentergem and colleagues. Starting with introduction, so the setup is that if you walk into any professional team today, whether it be soccer, rugby, or even American football, the athletes aren't gonna be like wired up. They're gonna have like monitoring. So some examples would be GPS units, accelerometers, heart rate monitors, etc. And so the point is we're not really short on data. Rather, the problem lies in the opposite. So we have so many numbers that practitioners often don't actually know what each one means in terms of how the body adapts. So coach can see a metric go up, but in terms of what? Maybe fitness, fatigue, tissue damage, we don't really know that. And this matters because the entire principle of training rests on getting load right. The right amount of load is going to drive improvement up, but if you have too much, you can tip athletes into things such as injury and illness. If you have too little, that's just not going to help as much, and the athlete is really not going to improve. And so the core complaint of the paper is that as a field, we've gotten really good at the physiological side, so the cardio, the energy systems, but we've largely like kind of ignored or skipped over the biomechanical side, or the mechanical stress on the body's tissues. And so that gap's what the paper focuses on. So for the framework, we need two definitions that the rest talk depends on. So first off is external load, and so something what the athlete physically does. So the observable activity. Some examples are distance covered, speed, and acceleration. Internal load, on the other hand, is the stress this activity causes inside the body. And this is the important one here because internal load is actually what drives adaptation. The same external load, say maybe a 5K run or swim, it creates a totally different internal stress in a deconditioned athlete versus an elite one. And so the key move the authors make is that internal stress comes in two forms. There's biochemical stress, and that's going to be your physiological pathway, the energy demand. And there's going to be mechanical stress, that's going to be the biomechanical pathway, the physical loading of the tissues. And so the kind of logic of monitoring here is that we're measuring external load because it's easy. And so in order to estimate internal load, which you can't really see, so ultimately you can predict adaptation of the human system. And so it's kind of framed as the chain here, and there's arguments about how that chain is going to split into two parallel tracks. And so the track I'm talking about is kind of the heart of the paper. And so the proposal here is kind of simple. And so we're going to stop treating training load as one thing, sorry, and treating as two separate load adaptation pathways running in parallel. And so the first off, we have the physiological pathway, and so biochemical stress on the aerobic, cardiovascular, and muscular systems. The adaptations you're gonna get are stuff like endurance, speed, and strength related to fitness. Next, we have the biomechanical pathway, so mechanical stress on the actual tissues, bone, cartilage, muscle, tendon. The adaptations here are structural changes to tissue itself. And so an analogy you could use, you have a diagram here that kind of outlines it, but analogy is maybe like a car. So the physiological side would serve as an engine. The focus is fuel and oxygen consumption and how much energy you're burning. And the biomechanical side is suspension, and so focus is keeping the whole thing intact and together. And so how do we actually measure these from the outside? So on the physiological side, we have a main called GPS. And so you can take distance and velocity and feed them into what are called metabolic power equations, or formulas that kind of estimate energy cost for movement. And this is something, there's a catch kind of here because these equations were built for more constant speed running or like movement. And team sport kind of breaks that law because there's a lot of acceleration going on, deceleration, start, cut, sprint. And so for that, GPS accuracy is actually going to get worse, which is what in the situations where there's a lot of acceleration, which actually matter in team sport. And so the estimates they gave with GPS are actually have some flaws in them. And so on the biomechanical side, it's driven by ground reaction forces, so the forces maybe pushing off and landing. And players perform maybe an estimate of around like 500 acceleration and deceleration in a single match. And so measuring those forces directly needs kind of like a force plate in the lab to really measure it, which is kind of useless on a pitch or like on the field. And so instead we're going to use accelerometers and combine with the Newton's second law and for a given body mass to kind of find acceleration in that way. And so these higher frequency signals kind of get crunched into a single number, which is called player load, and it's kind of a scalar built for that purpose. However, a flaw in player load is that it kind of correlates poorly with physiological measures like heart rate. And so for a long time, it's been treated as a problem. And so the thing with paper is that it actually flips it. So the poor correlation isn't really a bug, rather the whole point. And so it's measuring a different thing entirely, the biomechanical pathway, not the physiological one. Okay, by the way, sorry if I'm rushing, but I'm assuming we're in time limits. I'm just like kind of trying to get through it. And so now I move on to monitoring internal load. And so we're going another level deeper, which is the stress inside the body, which is hard to get at. On the physiological side, we're actually in pretty good shape. We have well-established direct measures such as heart rate, training impulse, or called TRIMP, I believe, oxygen consumption, blood lactate, and RPE, or rating of perceived exertion, which is just asking the athlete how hard it felt. And so these are all metrics that are validated and widely used. And so the biomechanical side is really where the gap exists. Ideally, you would measure maybe joint contact forces and muscle tendon forces directly, but that also requires a lab, and so you can't really do it while training. And so the field right now is kind of hunting for practical proxies, and the paper is going to walk through a few. So the first one is called a differential RP, so it's another form of RP. And so instead of the one overall question of just perceived effort, it's going to be two questions. And so it's just separating the breathing parts of the kind of cardio from the physiological load, such as leg exertion. And so it's kind of just RP, but split into two parts. And so the other kind of methods do have a few problems, like muscle soreness is delayed, like it's going to show up a day or two later, like when you lift, like so it's not going to show up immediately. And so it's not really as reliable. And creatine kinase level, or CK, is going to be a blood marker of actual muscle damage. It's more direct, and it actually does correlate to accelerometer load, but it's a bit hard to measure, and a single hard impact can really throw the whole reading off. So the bottom line the author can land on is that differential RP is the most promising practical tool we have for the biomechanical side. Okay, once we've loaded the athlete, we measured it, now what does the body actually do in response? On the physiological side, adaptation is really the textbook is convention. We understand it deeply, the heart, the lungs, capillary density, muscle fiber types, all of it. On the other hand, the biomechanical side, the authors point out, has never really been formally laid out before, and so they do it themselves. So what they say is that mechanical stress drives real structural adaptation in tissue, and so muscles will be the most responsive, like in strength training, this will be the most like adaptable. And next up, it comes cartilage and tendons, which both adapt to, like cartilage tissue that gets regularly loaded is able to get stiffer and more adaptable, and similarly, tendons can change too. However, these adaptations can be slow at times, and usually they're going to be much slower than the physiological changes and much more subtle. So at times they're being overlooked, and the only time when this really gets noticed is when it fails. So for example, stress fractures, tendonitis, and then by then the adaptation problem has been just like building basically for weeks. And that slowness is what's going to set us up now. And this is kind of the main kind of bit of the paper. And so what we're going to do is kind of picturing a series of identical training sessions at fixed intervals. So like say every 2 days. Now assume, just for hypothetical, that the biomedical tissue is going to recover about twice as slowly as the physiological system. And so what's going to happen is that the physiological system is actually going to bounce back fast. It's going to hit what's called a supercompensation. And so it's going to overshoot back to a slightly higher level than before. And so the next session is going to land kind of right at that peak. And so the whole idea behind it is that kind of be perfect timing and steady improvement session after session. But the biomechanical tissue is going to be on a slower clock overall, and so when the next session arrives, the tissue hasn't recovered yet, it's still weakened. So instead of building it up, it's going to get chipped down a little more, and again, over and over again. And each session is going to dig the hole deeper until you reach a critical weakness and the tissue is going to fail. Injury. Say it's going to be the same training plan, but two different trajectories, and one's going to be improving, the other's going to be headed for injury. So for the fix, I was kind of propose that during these vulnerable windows, we're going to reduce the biomechanical load specifically and let tissue catch up and sort of compensate before you load heavily again. But the problem is that you can only do that if you're able to control the two loads independently, which raises the question, how can you do this in practice? And so there's a few applications we have here, and so the kind of load splitting is it's already routine in some rehabilitation practices. So for example, aqua jogging and anti-gravity treadmills are some examples. So what it does kind of like lets an athlete keep the physiological load while um, cutting ground reaction force by around 20%. And so it's gonna be a full cardio workout still, but it's gonna be reduced impact on the body. And so there are much more examples, just like small-sided games, tricking the pitch, and you can actually lower the physiological demand, but raise the biomechanical one. And for example, like HIIT, high intensity interval training, it can give you high physiological load with relatively lower impact, which is the kind of session you want to slot into one of those vulnerable windows I was talking about. And another example is sprinting on sand instead of maybe grass or turf. It lets athletes hit maximum intensity, so high physiological load, while a soft surface is going to absorb the impact on the tissues. As a conclusion, it's kind of tying it together. So this call to action is just the first is to differentiate the two pathways when you monitor and program, and also engage more seriously with the biomechanical literature because that's been kind of neglected for a while. And so the physiological science is already there, but the biomechanical science exists, but just really hasn't been pulled into yet. Just quick note limitations. This paper is very theoretical, so it doesn't really have a lot of novel, like true applications, just to know. Here are my references. Thank you. Are there any questions?
Does anyone have any questions for Jason or Dr. Lopez? Do you have any insights to add?
No, that just be quick. You can take this off of share. Um, what's interesting is that to reach approximate workload of a match or game, and this is why they always have scrimmages just before the season. The issue is that you need to bring up the workload up to approximation of what it would be during the normal season. And so that's why they have scrimmages beforehand, always, because there's no way you can replicate or match competitiveness. And why do you think they have friendlies? Right? Didn't they have like friendlies for all the teams just before the Rugby World Cup? You can move out of this. You could close out of this, sir. Thank you. And you can move out of the sharing mode. So if you understand what I'm saying, um, sorry, I had the lights off so I could see the presentation. The approximation of workload for the game will never be made unless they play a game. So everyone knows what I'm talking about, right? They had friendlies before the Soccer World Cup, yeah? What do you think that was? That was to bring up the workload to approximate what the matches would be like. Yeah, they probably jogged a little bit more. They played a little, not as hard, but they still had to compete. They still had to play, right? And so that's why it's kind of interesting. They'll always have a preseason match or a preseason scrimmage, and that's beneficial for the team. I think that is very underused in rugby. What we would always do is probably why we played for a lot of us really played for a long period of time. And that was because we would do 3 to 4 matches up in Canada before we would start our season, just to approximate our work. We didn't know any better per se. We just wanted to get those matches under our belt, more for confidence, team building, team bonding, which also has certain, factors in that. But let's quickly move on because there's a bus to catch.
Thank you so much for that insights, Dr. Lopez, and thank you for a great presentation, Jason. Our next intern presenting will be Brendan Zhu. I will let you introduce yourself in your presentation, and you're welcome to start screen sharing whenever you are ready.
Thank you, Danielle, for the introduction. Can you guys see the presentation? My name is Brendan. I'm a rising senior at Lexington High School, and today I'll be presenting on mitigating traumatic brain injury and a narrative review on supplementation and dietary protocols. This review was done by Conti and colleagues in the Nutrition's Journal in 2024. So, a bit of background on TBI and its prevalence. According to the CDC, almost 214,000 TBI hospitalizations in 2020 and almost 69,000 TBI-related deaths in 2023. To put that in perspective, that was about 586 TBI hospitalizations per day and 190 TBI deaths per day. And also, according to the CDC, the TBI affects around 500,000 U.S. service members in the past 20 years. TBI is classified in 3 categories: mild, moderate, and severe. And within those 3 categories, there are 3 factors that contribute to the classification: duration of unconsciousness, the Glasgow Coma Scale, and the post-traumatic amnesia. From the table on the right, you can see the markers that determine whether it's mild, moderate, and severe. The Glasgow Coma Scale, this is from the SCAT-6, determines three categories: the best eye response, best verbal response, and best motor response. The best eye response is scaled 1 through 4, 1 being nose, eye opening, 4 being eyes opening spontaneously. Best verbal response is scaled 1 through 5, no verbal response for 1, and oriented 5. For best motor response, 1 being no motor response, and 6 being obeys command. These three scores are added up to determine the final Glasgow Coma Scale. The injury mechanism for TBI occurs in two phases. The acute phase is the initial phase right after injury. When the injury occurs, glucagon begins to flood the brain, which causes exotoxicity. And when this happens, it causes an imbalance between the calcium and sodium ions in the brain. This causes the production of reactive oxygen species, which damages the mitochondria and reduces the amount of energy and ATP that is produced. The brain tries to offset this by going into anaerobic respiration, but it still ends up in an energy deficit. Because of this energy deficit, this causes apoptosis and cell death. It also leads to DNA fragmentation and misfolded proteins. The second phase of TBI is the delayed and secondary phase that happens weeks and days after the injury. The main markers are neuroinflammation and the blood-brain barrier is disrupted. The diagram on the bottom illustrates what the blood-brain barrier is. In the image, it's the purple things, purple junctions between the blood and the brain. When the blood-brain barrier is disrupted, it causes immune cells to flood the brain. When immune cells flood the brain, it causes the release of cytokines and also the releases of ROSs and glutamate that cause more damage to the brain. So the purpose of the review study is to summarize the available literature on the effects of selected nutrients in context of TBI outcomes, and to see which nutrients that can be implemented into diet to help reduce the effects of TBI. In addition, it also proposes protocol for supplementation and diet post-TBI. The methods that it used to collect its review papers, it uses two databases, PubMed and Cochrane. During their review, they mainly focused on systematic reviews and meta-analysis, and they focused on peer review English review papers. And they found these papers through keyword searches using nutrients, food, and biochemical compounds alongside TBI. They screened these research papers through reviewing their titles and abstracts and then reviewing full body text. They decided to include both animals and human tests. The results that they found is that they found 11 nutrient compounds that they had evidence for to help reduce post-TBI. Some of them being omega-3 fatty acids, creatine monohydrate, magnesium, and others. The number next to the compound lists the strength of evidence that they found, 1 being the strongest evidence and 5 being the least strongest. Out of all the compounds that they found, most of them were 2 and 3s. And using those findings, they decided to conduct a supplemental plan. Based on each compound, they decided to list the amount of grams of that compound or nutrient that each person should take a day post TBI. In addition, they list adverse effects such as creatine monohydrate. There may be mild gastrointestinal distress with over 10 grams. In addition, BCAAs also cause mild GI distress over 45 grams. In addition, the research paper also illustrates food sources for these nutrients, such as for omega-3 fatty acids, it lists salmon, herring, sardines, mackerel, and trout as sources for omega-3 fatty acids, and also lists how much grams of omega-3 fatty acids are per 100 grams. In addition, they also add non-nutritive compounds, which are compounds that do not have calories to them. In this, they also list the amount of grams that should be taken per day and if there's any food sources. For example, blueberry anthocyanins, which are the pigment and blueberries, those should be taken 250 to 400 milligrams a day, and it can be taken through wild bush berries. Others can be taken through medications that can be bought. Other considerations that they considered were caffeine and sleep. Those who took caffeine post TBI in order to reduce fatigue, in order to decrease their time and get back to injury activity, they found that vascular occurred, which is the constriction of blood vessels in the neural. They also found that poor sleep quality, higher rates of depression, and somatic symptoms, which are physical symptoms such as higher pain and shortness of breath. Therefore, they concluded that they should reduce post TBI, should reduce caffeine consumption in order to prevent these symptoms. They also focused on sleep. Often with TBI, those experience disruptions in sleep cycles and sleep syndromes, which often cause slower recovery, fatigue, and headaches. They suggested regular sleep schedule, sleeping the same time every day, and minimizing screen time 1 to 2 hours before bed and overall in daily life. And those who still struggle with sleep should consider taking melatonin in order to help them sleep and start the recovery process. Overall, they summarize this approach called the left bang approach. They also add a pre-impact approach. They suggest those should take a pre-impact assessment, measuring certain health statistics such as omega-3 status and vitamin D in order to prevent any negative outcomes from recognize any negative outcomes from TBI. In addition, they suggest taking these supplements that are found used for post-TBI and implement them into prior to the TBI incident, such as taking creatine, omega-3s, choline, magnesium, and eating berries before any TBI incident occurs. And after TBI incident occurs, they suggest regulating thermal regulation and also blood glucose levels to avoid high blood sugar levels. And like I said before, also to monitor and minimize caffeine use and prioritize sleep optimization, such as sleeping at the same time each day and reducing screen time. And the post-impact supplementation, these creatine, omega-3s, choline, magnesium, and berries and BCAAs are the essentials that they suggest to take post-TBI. Others that they also suggest, such as melatonin, are more on a case-to-case basis, and throughout their studies did not find that everyone needed the same exact supplements to be taken. Some of the limitations of their study is that the supplements were studied in isolation. All of the supplements were studied alone and not in a combined protocol that this paper suggests, which concludes that they cannot predict the effects of taking all these medication and supplements at the same time. In addition, the research papers that they collected were small sample sizes, short follow-up periods, and heterogeneous populations. So they cannot conclude that what the predicted outcome will be the same. Dietary supplement industry was also not appropriately regulated by the FDA. They found that certain supplements that were given during the studies, they cannot guarantee that the supplement labels were accurate in the amount of milligrams they were given to the test subjects. In addition, animal studies were used, like I mentioned earlier, and they cannot conclude that the animal studies that were used have a clear translation to human expected outcomes. They concluded that there are evidence-supported compounds and supplements for the use of TBI in helping reducing the symptoms, such as creatine, omega-3 fatty acids, etc. They also concluded that personalization is important when it comes to supplementation, and that it is important to take a screening and also consider the injury severity, as TBI is very variable in its symptoms. In addition, they suggest that further clinical work is needed in order to understand the mechanism associated with TBI and to build a standard protocol, as TBI still is very understudied and unknown and has a lot of variability when it comes to the symptoms. And these are my references. Thank you.
Thank you so much, Brendan. Does anyone have any questions for Brendan?
No, very good talk there, Brendan. Not only that, it's a very difficult topic to try to see if you could try to get nutrients to evaluate the benefits or the progression of traumatic brain injury. Thanks so much. It's a tough topic.
Beautiful. Yes. Thank you, Brendan, so much for that topic. Righty, now we can move on to our third interim presentation. Next up, we will be having Kevin Serrano. Kevin, I will let you introduce yourself as well as your presentation, and you are welcome to start screen sharing whenever you are able.
Can everyone see my screen correctly? Perfect. Hi, my name is Kevin Serrano. I'm a rising sophomore from Brandeis University. I live in New York. And today I will be presenting on sleep and performance in professional athletes, a article published in the Current Sleep Medicine Report Journal in 2023, published by Cook and Charest. So epidemiology of sleep. Sleep plays an essential role in biological, physical, and cognitive health, especially for athletes. It heavily influences the athletic ability, the bodily recovery process, and the peak level performance that athletes can have during intense competition. The interest and importance in sleep has actually increased drastically within the last decade, with many different athletes and organizations increasing the amount of awareness around the situation and the the difficulty of getting good sleep. One of the main reasons that sleep has been difficult for athletes is because of the rigorous athletic schedules that they go through, which includes training and traveling, which we will get into more as in this presentation. So just a quick summary of the stages of sleep. There are four main stages of sleep. The sleep onset is one of the shortest periods. It's the transition from wakefulness to sleep. It's the beginning of the sleep cycle where you just lay down in bed. Then continues light sleep. It's a stage of light, easily disrupted sleep where the body starts to relax and slow down. Then deep sleep. This is the most important and crucial part that athletes need to prioritize the most. It is where the most restoration of any physical injury occurs. There's the most amount of immune system strengthening happening in this section and the most amount of physical recovery. And the lastly is the REM cycle. It's a phase characterized by vivid dreams, essential for emotional regulation and memory consolidation. It's where the brainwaves are the highest, and this is where dreams mostly occur. So the methodology and purpose of this article. 38 articles were utilized in this literature review. It compiles published literature from 2018 to 2022 on sleep with professional athletes. Interestingly enough, amateur and Olympic athletes were both omitted from these journals. It identifies the sleep role in training, physical injury prevention and recovery, competitive performance, mental health, and encompasses the importance of what sleep is. Common sleep problems and disorders is really covered in this article. The influence of unique challenges also are covered in this article with training and traveling, especially with scheduling, competition, and other unique situations, circumstances that we really experience more in the modern era, which with nutrition, electronic use, and physical injury and illness. Sleep and training relationships. Sleep quality and regularity correlated to decrease in illness, fatigue, and injuries, an increase in effectivity and performance ability and energy, and a qualitative amount of testosterone and cortisol levels. Looking at the diagram on the right, you can see that there's a study coordinated that looked at the different sleep cortisol levels and the IL-6 protein levels within people who had an insomnia disorder and using a control group. Looking at the cortisol levels, you can see that the amount of cortisol that was found within the blood of people who had an insomnia disorder was clearly higher than people who were in a control group. And in addition to that, the IL-6 protein, which is more responsible with immune system function and responsiveness, was much lower in the insomnia disorder group compared to the control group. Another important thing to keep in mind is the quantity of sleep that you get versus the quality of sleep that you get. Quality in general has been found to be more effective than the quantity when it comes to lowering cortisol and other hormonal levels, as well as feeling better in general as an athlete. The best ways in order to be able to improve that sleep quality or really like measure the sleep quality is by looking at the reduced sleep latency, which is how long it takes for you to fall asleep as soon as you lay down, minimizing the amount of interruptions throughout your sleep, and looking at the efficiency by using the 85% rule, which states that you really sleep 85% of the amount of time you're actually laying down. Physical injury prevention and recovery. Sleep might not have as much of an effect on delayed onset muscle soreness as once previously thought, which is something very interesting that the article brought up. Um, Outside of that, it also brought the reinforcement of the correlation between lower cortisol and higher testosterone levels in athletes who have better sleep quality. Looking at the diagram on the right, we can see that looking at sleep duration, athletes who sleep between 8 to 10 hours of sleep have the highest testosterone levels compared to any other category. Mental health implications. Mental health is on one of the biggest sections and that really determines whether or not an athlete can perform or not. One-third of elite athletes, including professional Olympic, experience mental health problems. Sleep and mental health shares a bidirectional relationship in the sense that one can affect the other. So sleep can affect mental health, and mental health can affect your quality of sleep. Looking directly at the article, it quoted an article that had a sample of rugby players over a 12-month period, where 28% recorded depression, anxiety, 22% reported adverse alcohol use, 12% reported eating disorders, 11% reported sleep disturbances, and 19% reported two or more concurrent symptoms at the same time. So this is clearly a problem that influences not only sleep but also mental health, so showing that bidirectional relationship. Multiple sleep monitoring measures that were done within this different researchers that were covered in this article showed that with improved sleep quality, there was a 31% to 51% variance in depression and anxiety levels in athletes, which shows the effectiveness of having quality sleep. Competitive performance. Keeping it simple, poor sleep affects competitive performance via previously mentioned indirect pathways, translating into slower reaction times, emotional dysregulation during competition, lethargy, a decrease in athletic ability with your agility, speed, power output, and other different factors decreasing, and an overall lowering in the VO2 max that an athlete can have during competitive. The Pittsburgh Sleep Quality Index, the PSQI. This is one of the biggest uh, surveys that's used in order to try and really see the quality of sleep that a person can get. It's a self-answered questionnaire. It scores from 0 to 21. So every time you answer something that might show worse sleep quality, your score will increase. So a score of 5 and greater indicates poor sleep quality, and it encapsulates the sleep quality over a 1 month period. Interestingly enough, the article quoted that poor scores translated to poor performance even when nutrition was no longer a factor. This was especially apparent when looking at samples of players who were fasting during Ramadan, where although they were not having enough nutrition or the correct nutrition because of their fasting periods, they were actually having better performances when they had better quality sleep, which is really interesting to know. This is a better look at this Pittsburgh Sleep Quality Index. As you can see, it's a fairly simple sleep survey that most players fill out. You can see when you usually go to bed, how long minutes are you taking to fall asleep, etc. And taking these scores into account, it goes through an algorithm in order to calculate the correct score and really tell you whether or not you have any sleep problems, sleep issues, or in general had difficulty just throughout the entire month that might correlate to different performance or fluctuation in performance. Another key factor was traveling in time zones. Higher travel times directly impacted sleep. Time zone changes resulted in jet lag increase, and the PSQI scores increased proportionally with the distance traveled and the amount of time zone changes that athletes experienced. As you can look on the right, you can see this is directly quoted from the 2024-2025 season from the NFL, showing that the amount of time, distance, and time zones that different teams have to go through in order to compete every single day. Here at the top, you can see that the Los Angeles Chargers nearly traveled 26,000 miles in one season, going through 36 different time zone changes. And the lowest, even though the Washington Commanders didn't travel as much, they still experienced 18 time zone changes, which really shows that this is something that's really difficult to avoid, especially when performing at elite levels. Um, in addition to this, data showed that NFL, NBA, NHL teams' win percentages had an inverse proportional relationship, meaning that if teams were to travel more and teams were to have more longer distances to travel and more time zone changes, their sleep was impacted and their win percentages were, as a result, decreased. Interestingly enough, there's also nearly no effect on the afternoon games but high effect on the evening games. Basically meaning that those evening games, since they ran longer, it would be harder and more difficult for athletes to be able to condition themselves to go to sleep right after because of higher cortisol levels during athletic performance. Also taking into account time zones, we can see that the west to east traveling teams is a harsher and more difficult traveling time and has a higher impact on sleep than the east to west travel. This is mostly because when you're traveling west to east, you actually move forward in time instead of east to west, where you gain more time going backwards, which straight up affects the circadian rhythm and affects sleep quality. Common sleep disorders. The two of the most common sleep disorders that happen are insomnia and obstructive sleep apnea. Insomnia is characterized by difficulty of falling and slash waking up from sleep and staying asleep. Nearly one-third of athletes experience at least one or more of these symptoms, even though they're not directly from insomnia. They are still symptoms that they experience. As a result of these symptoms, they do cause daytime drowsiness, which can directly affect the performance of an athlete. And one of the best ways to see whether or not you experience any type of insomnia symptoms is using the Insomnia Sleep Index, the ISI. And using one of the articles that the paper used, 28% of pro soccer players had a sub-threshold insomnia symptoms, basically meaning they had one or more symptoms being shown for insomnia. And then the obstructive sleep apnea is another disorder that's very common, especially in the general population and in athletes. It's characterized by difficulty breathing during sleep. It causes many interruptions. Home-based polysomnography showed that 45.4% of adult professional rugby players had mild or severe OSA. This is from a select sample. This isn't the entire um, population of professional rugby players, but this is a select sample that showed 45%. And direct effects, this apnea has direct effects on previously mentioned athletic measurements, meaning that apnea leads to disturbances in sleep, which leads to different effects that were mentioned before. Some of the unique challenges and factors that athletes experience. So, physical injury and illness are something that is very common in athletic life. Weaker immune systems occur as a result of poor sleep, as a result of the IL-6 protein that I mentioned earlier. In addition to this, injuries influence the mental health, which, as for the bidirectional relationship that they have, it can lead to worse sleep quality as well. Nutrition was something the paper also mentioned, the fluctuation of meal timing. Teams that are traveling a lot more, teams that have longer away days, have a lot more fluctuation of their meal timing, which as a result causes different melatonin output and causes worse sleep quality. Higher protein consumption also resulted in worse sleep quality and sleep onset, which basically meant that players who consumed more protein, interestingly enough, displayed worse sleep quality, and it became harder for them to fall asleep. And it's commonly known that caffeine consumption is very connected towards interruption in sleep because of its effects that it has on the brain, where it covers this receptors for melatonin to be able to bind, and um it causes it to be harder to sleep at night. And then electronic use, evenings and late night usage have directly had effects on athletes, basically showing that if you use electronics later at night, it's going to have blue light effects where basically it affects your circadian rhythm and causes you to think that your body's in the daytime, even though you're really at night. And then just the addictive nature of electronic use. Many people use electronics in order, to get away from their athletic lives and their stressful lives. And it ultimately causes them to neglect that side of sleep and be able to take care of themselves. And the possible interventions, there was three main ones that the paper cited. The first one that they mostly cited was the sleep health education, really teaching athletes and understanding what sleep health really is and what it really means to sleep appropriately, really tackling the problem at its source, letting athletes know. And as a result, that would also lead into the second point, which is advocacy and institutional mindfulness. Advocacy would come as a result of the athletes knowing what they need and knowing that they need the proper sleep at night in order to be able to perform every single day. And also being able to talk to institutions like the NFL, NBA, NHL, etc., in order to be able to create schedules that are friendly towards healthy nights of sleep. And lastly, it's external treatment. Looking back at the disorders that were mentioned before, external treatment is very common with those in order to be able to prioritize sleep quality. And in addition to this, other medications like melatonin would help with sleep quality in order to be able to improve that quality of sleep that athletes get every night in order to be able to really recover fully. So some of the key takeaways were sleep is essential for elite performance competition. Sleep has direct and indirect ways on a multitude of key hormonal, mental, and physical pathways. The lack of issue addressment and scheduling ignorance is something that cannot continue to happen, or else the abuse of athletes will continue until who knows when. And the performance over health prioritization is something that a lot of athletes need to understand because if they don't, they're going to continue to destroy their bodies slowly. And some of the article limitations that I saw was the generalization of sleep in sport. There was really too many assumptions made by the paper for a large scale study. They would really take specific articles in order to kind of make a general consensus about everything. And when in reality, it's much more specific because you can't compare the way a rugby player plays and trains compared to somebody who plays soccer or plays tennis. So I think that was something that was very um something that they should look over or something that we should look into more. Really look into specifics of each sport and see how they can adjust their scheduling or habits in order to be able to prioritize that sleep. And then the lack of information and consensus on the correlation of sleep and direct effects on both the physical injury prevention and recovery and the mental health. There were a lot of different gaps that were found within the information where the paper really just stretched the truth in a way. And it really showed because most of the points that were made weren't really directly connected to, sleep and are given specific data points on how sleep will affect mental health or sleep will affect your injury prevention and recovery. Another thing is the time constraint. They only use papers from 2018 to 2022, which doesn't really give the whole idea of what it means to be an athlete. Athletics has been happening since hundreds of years ago. So I believe it would be better to have a broader range of articles to be able to look at in order to be able to really make good points. And like I said before, the lack of specific data really affected the way the articles' points were being made. Most of them were based off of different quotes that articles use instead of really using specific data from, for example, the Pittsburgh Sleep Quality Index or other different types of questionnaires that might really help accentuate that point. And here are my references. The photograph was for the sleep cycle was from Zden and the article that I just went over. And thank you.
Thank you so much for that wonderful presentation, Kevin. Does anyone have any questions for him? Dr. Lopez, anything to add?
Any questions from anyone first? Well, I really like that you brought in a lot more imagery. It really puts together the visualization of and maybe most of those images came from the study themselves. But I think what happens is that you get to see, what the time is when you're going across time zones of things of that nature. They didn't discuss rugby in this study, did they?
They had a few references to some rugby studies, but it was really generalized.
It was really generalized. I noticed that. Um, Interesting. Like I said, because I think one of the worst circuits is the seventh circuit that bounces all around the planet with the time zones. They're going, every 2 weeks to a different, you know, country and city. Anyway, that it does show that, or the paper does reflect that there is a correlation with injury and, rest. So this is something that we need to keep in mind, and I think we've always been trying to push to make sure that the athletes are rested well, well rested, you know, even scheduling the coaches and captains meetings beforehand, before the tournaments, early enough so that this way they can move into their schedule or their timing of how they should go to sleep prior to the tournament. Again, very interesting. I appreciate you bringing that up. It's really kind of a topic that needs to be, implemented more, if that's the best way of saying it.
Thank you, Dr. Lopez. All right, everyone, that will conclude week 2 of the RISE Institute and Rugby Research and Injury Prevention Group Sports Science Series. Thank you all so much for attending and have a beautiful night.